Okay, so I'm going to show you how to solve the system of literal equations ax plus by equals ab and bx minus ay equals b squared. I'm going to do this using substitution, which is not recommended. Instead, we use the elimination method because it's much easier, much quicker. But I do want to show you that this way at least works in case you do choose to use it. But it is more intensive. Okay, so we need to pick one of the equations and we need to solve for one of the variables. So I'm going to pick the first equation and I'm going to solve for y. Okay. Okay, so to solve for y, we are going to take ax away from both sides. So let's go ahead and do that. Okay, so this will then give us by by itself on this side. It's going to equal ab minus ax. Alright? And then to finish off solving for y, we're going to divide by b on both sides. Alright. So then what this is going to do, this will give us y equals ab minus ax over b. Okay? So now we're going to take that and we're going to go plug it back into the other equation. Okay? So remember we had bx minus ay, which I'm going to replace y with this whole expression here. Bx minus a, and then in parentheses ab minus ax all over b equals b squared. Alright. Now just to make it a little bit easier for ourselves, I'm going to distribute that a. It's going to be bx minus a squared b minus a squared x all over b is going to equal b squared. Okay. Now my next step is going to be, and I'll do this on a new page, I'm going to split that fraction up into two fractions. Again, I'm trying to get the x terms by itself, so I'm going to take that fraction and split it up. I'm also going to distribute that negative. Okay? So what that means is I'm going to get bx minus a squared b over b plus a squared x over b. Okay. That's going to equal b squared. Alright. Now there's many ways I can go here. But what I'm going to do is, I notice I've got an equation with fractions, so I'm going to try to clear them. And if you notice, our common denominator is b. As a matter of fact, it's our only denominator. So we're going to multiply everything in this equation. We're going to multiply both sides of the equation, which means we multiply basically everything in the equation by b. Okay? Which means we're going to get b squared x minus the b's will cancel. The b will cancel off the denominator, so this is going to be a squared b plus the b will cancel off this one, so it's going to be a squared x. That's going to equal, and then b squared times b is going to be b to the third. Okay. Now I want to get x by itself, which means I want to get the terms with x onto one side. Which means I'm going to get the negative a squared b by adding it, and I'm going to add it to the other side. Okay. Alright, so here's where we're at. We're at b squared x plus a squared x is going to equal, I'm going to just put this in order descending order according to a, so it's going to be a squared b plus b to the third. Not that that matters, but just more pleasing to the eye. Okay? Now on the left side, we've got two terms. They're not numbers. We can't combine them. So I'm actually going to factor out the x. That's the common factor. Okay? So when we factor that out, we're going to get a squared plus b squared equals, and you're going to see, I'm going to do this now, but you could do this later. On the right side, I'm going to factor it out as well, just to see it in factored form. This might help us in the next step when we start canceling stuff out. So I'm going to factor out a b, and you're going to get a squared plus b squared. And you'll find a lot of the times in these literal equations, when in doubt, factor. Okay? Okay, so now to get x by itself, I need to divide by this factor of a squared plus b squared. Okay, so that'll cancel it out on that side. Let me do it over here as well. Okay. And if you notice, it's actually going to cancel on this side as well, which is very convenient. It works out very nicely. It just shows us that x equals b. Okay. Now that we've found x, we can take that value and plug it into either one of the original equations, and now we can solve for y. So, since in the example on the module we picked the first equation, just to kind of mix it up a bit, I'll plug it in back into the second equation just to show you that it works out. Okay? So if you remember, the second original equation we had was bx minus ay is going to equal b squared. Okay? So I'm going to take, we know that x equals b, I'm going to plug that in for x, so it's going to be b times b minus ay equals b squared. Okay? Which we know b times b is b squared. Okay. Now remember, I'm trying to solve for y, which means I need to get rid of the term that doesn't have a y in it. So I'm going to subtract b squared from this side. And again, kind of convenient on this one that when we subtract it from the other side, it actually comes out to 0. So that means we get negative ay equals 0. And just to make it official, we could probably see that y is going to be 0, but just to make it official, I'm going to divide by negative a, okay, which tells us that y equals 0. Okay? So we know our x value is b, our y value is 0. We can express our answer as an ordered pair, b0. Okay? So I'm just showing you how to do this by substitution, but you can see how intensive it gets. So probably better to stick to the elimination method.